వెల్కమ్ టు ATL వే టు ఇన్నోవేషన్ సెషన్. అందరికీ కూడా స్వాగతం సుస్వాగతం. నిర్మాణ్ లెర్నింగ్ త్రూ ద థింకరింగ్ సెషన్స్ కి. సో ఈ యొక్క ప్రతి ఆన్లైన్ సెషన్ లో మనం కొత్త అంశాన్ని నేర్చుకుంటున్నాం. అలాగే మీరు అందరూ కూడా అంశాన్ని ప్రాక్టీస్ చేస్తున్నారని చెప్పి అనుకుంటున్నాను. సో ఇవాళ మన సెషన్ లో ఆర్డినో IDE సాఫ్ట్వేర్ గురించి మరియు దాని యొక్క కోడింగ్ ఏ విధంగా ఉండాలి, ఏ విధంగా ఉంటే మనం డిఫరెంట్ ప్రోగ్రామ్స్ ని ఏ విధంగా కండక్ట్ చేసుకోవచ్చు దాన్ని ఉపయోగించుకుని అనేది చూస్తున్నాము. సో ఈ యొక్క ప్రోగ్రామ్ ని మీకు సమర్పిస్తున్న వారు గవర్నమెంట్ ఆఫ్ ఆంధ్రప్రదేశ్, డిపార్ట్మెంట్ ఆఫ్ స్కూల్ ఎడ్యుకేషన్, సమగ్ర శిక్ష, SCRT, UNICEF అండ్ కండక్టెడ్ బై ద విజ్ఞాన్ ఆశ్రమ్. సో మై కొలీగ్ విపుల్ మీకు ఈ యొక్క ఆర్డినో IDE సాఫ్ట్వేర్ గురించి విపులంగా చెప్తారు. సో మీరందరూ కూడా తను చెప్పేది ఏంటనేది కంప్లీట్ గా అర్థం చేసుకోండి. దానికి సంబంధించినటువంటి తెలుగు ఎక్స్ప్లెనేషన్ నేను ఈ టాపిక్ అయిపోయిన ఎండింగ్ లో లాస్ట్ 5 minutes లో మీకు ఎక్స్ప్లెయిన్ చేస్తాను, ఏ విధంగా దాన్ని మనం చూసుకోవచ్చు కూడా. ఓవర్ టు యు విపుల్.
Thank you, Rajiv. So, before starting the session, there is one announcement regarding the ATL marathon, as you know. So, the last date of submitting your ideas and projects is on the 10th of April. Before the 10th of April, you have to submit your project. Okay. So, there will be 4 key sectors, as you can see on the screen: healthcare, nutrition, education, energy, transportation, and social inclusion. By using these terminologies, you can create your project and submit your ideas. Okay. Okay. So in the today's session, what is the today's session agenda? What we'll going to learn in today's session? These are some objectives. Installation of Arduino IDE and software. So how to install this Arduino software and why it is necessary, that we are going to see on this today's session. And the basic LED program. In the last session, we have seen some LED blinking program on the Tinkercad by using block view, right? So in today's session, we're going to learn by same things by using Arduino code, and we'll see how to do the coding as well. For that, we need some input-output devices. Prior knowledge is necessary. That is input-output devices, analog and digital pins, and we're going to do some basic Arduino coding. Okay. So what is Arduino Software IDE? What is Arduino IDE basically? It is an open source software. So all the time, so if you are doing some projects, it is not all the time possible to do the projects on the transistor or sub switch kind of things, so basic programs. Sometimes we need our project to get at the bigger level. We need some intelligence in our project, right? So for that, we are using Arduino, which is a microcontroller which has its own brain. We have to train that brain to achieve our projects. We have to do some coding for that project, right? So for that, we can use some Tinkercad software that we have seen in the previous session. But there is one another alternative and best option is downloading an Arduino software. That is nothing but a Arduino IDE. So you can go to this Arduino. This is URL. You can just go on some browser and just type this URL. I have already typed. I'll just show you again. So otherwise, if you copied that link, that is also fine. Or simply you can type arduino.cc. Okay. If you type that URL, some interface will show like this. So just go and explore the things like what is this, what is hardware, what is software, cloud, documentation. It is always better to start with the documentation part if you want to learn some new things. So getting started, Arduino documents, they have given you some inbuilt built-in examples, like you are using some sensors for your project, right? LEDs, switches, and all these things. So in there, they have already given you some examples. Then you can refer that examples to do some projects. And they have already explained you some of the projects like this. Predictive maintenance. This is one of the good project that you can look forward to it. So just if you don't know the meaning of this, just go on the Google, just type the predictive maintenance, and you'll able to see what is the things that are there. Okay. So we have to go on the software link. So here you can download the software by selecting by your operating system. We usually use the Windows operating system. If you have Linux, then you can choose one of the option from this. And if you have Windows 7 or newer than this, then you can just click on that, or else you can download the zip file for Windows. Or another option, you can able to get one app for your Arduino IDE. So I'll recommend that you should download the zip file rather than app. So it will be very useful for creating, if you created one project, it will be folder structure will be proper for that. Okay. So for that, you can download the zip file. So let's see what another things like that. Hardware part. So we are familiar with this Arduino controller, right? Arduino board. So there are a lot many another Arduino is available with us, right? This is the very familiar and common Arduino. Similar like Arduino Nano, Leonardo, and there will be lot of another things were there, Arduino cables. And there is one thing like Arduino Nano BLE. BLE stands for Bluetooth Low Energy. So as you have seen, some people used to wear some smart watches in their wrist, right? So that what that smart watches will do, they are monitoring our health, they're monitoring our heartbeats, they're monitoring our sleep tracking, how much sleep we have done, how much hours for sleep we have done, how much distance we have walked. That some kind of watches are working on the technology called BLE. So you can just explore the thing afterwards. It is not mandatory, but you can able to get the things like how much technology is ahead and currently what is going in the current market. Want to download the donations, so you can choose just simply just download without giving any pay. Okay. So you have to save, and it will be downloading as a zip file, and it's a 200 MB software. So currently I have downloaded it. That's why I'm not going to download it again. Once you have downloaded it, just you have to unzip that software and just launch it. That is not that much difficult. So you can just go forward to it. Okay, let's get back to slides. So next thing is like, let's see what we are last time where we are. Let's go on the Tinkercad first. Tinkercad, you might be aware of this. The recent sessions we have talked about this. We can run our electronic circuitry on this. So if I go on the Tinkercad, just I have to go on the circuits. Okay. So I'm now creating one new circuit. So instead of basic components, I'm choosing all over here, and I'm just typing Arduino. So Arduino, inside that I'm choosing one Blink program. Okay. So if we go on the code, which code is already here inside this controller, this is already displayed. So last time we have seen this, right? This section, block section, we have learned. That is LED is getting high for 1 second. After that 1 second delay, and we are making the LEDs low again for 1 second. So if I do the simulation, start simulation, we can see that LED is turning on for 1 second, turning off for 1 second. And see, there is one inbuilt LED as well, right? So we can see like that. And if you want to see the how actual code looks like, then you have to go on this code. Instead of block section is there, you can click over here and go on the text. So this is one code. Okay. So what we can do, we can directly, if you want to do it on our actual hardware instead of software, like instead of Tinkercad, if you want to program your Arduino code, then what you can do, just copy this thing. This // thing is a commented part. This is not compiled by this program controller, so we can ignore this part. Whatever it starts with a slash, just the remaining part we are copying. Control C. I'm doing. After that, I am opening my Arduino software. I'm just simply typing Arduino over here. I'm opening Arduino software, and I'm deleting this previous code and pasting whatever I have copied from this here. So LED built-in is nothing but if we have our Arduino, LED built-in is LED which is present on our Arduino board, which is situated over here and which is connected to pin number 13 of your Arduino. Okay. So instead of LED built-in, you can simply write as a 13 to all these things. That is also fine. Now I opened my Arduino software and I will write my code over here, right? So we have to see what else there is. Some options were there now. This is one compile option, this is upload option, this is opening option. If you have already stored code in your computer, you can Just click on this and find out that code where it is, and you can able to open that code over here, and you have to save this code. Now I have copied pasted this code. Now I have to save this code. Now I am giving some proper name for this LED sample. Okay, sample I am typing. So I am saving this. After that, I have to compile this code. What this compiler is doing is just checking the code whether you are making any some mistakes or that. You can able to track this. If you suppose I have accidentally forgot to put some semicolon on this code, I'll just compile this code. Now some error will be displayed like expected semicolon before the curly bracket. So see, it's indicating in the red color. So it's showing that semicolon is missing. So I'm just putting the semicolon and compiling it again. So it will get compiled. Now I have to upload my code in my Arduino. So what I can do, I'll take some Arduino cable like this, okay, which is also called as a USB to TTL cable. Okay, so I'm just currently in my one of the comfort of my, and I'm connecting that Arduino. So as you can see, this Arduino is get powered on. Right? So if I want to upload this code, what I have to do, I have to select the COM port. I am using my laptop. It has 2 to 3 COM ports, right? For every CPU, it also has 2 to 3 COM ports. Which particular COM port we have selected for this Arduino, we have to select here before uploading that code, right? So we have to go on the tools. We have to see whether we are using Arduino Genuine board. If you are using Arduino Uno board, you have selected correct one. If you are using some another controller, then you can select it from this range. Okay, and now I have to select the COM port. Now it's showing the COM7 Arduino. I am just going to select this. But what will happen sometimes in your computer, it will show like only COM7. So for that, if you have only one option, then you can select directly that. Suppose if you have some multiple options like COM3, COM5, COM7, then how you can able to see that I have connected my Arduino on the particular COM port. For that, you need some specific COM port, no? So for that, what you can do, you just go on your file manager and go on this PC. Just right click on that, and go on the manage tab. Okay. After going on the manage tab, just go on device managers. After going on the device manager, you have seen the number of options. Here, one of the option is called ports, COM and LPT. If you expand this option, you can see the Arduino Uno and COM port is mentioned as a COM7. Now I am removing that my Arduino from this. So it will get refreshed and there will be no option for ports. Okay. So I'm connecting back my Arduino. So I can able to see my COM port is COM7. If you have some another COM port, you can just select that COM port. Okay. Now my is COM7. Okay. So now I am going on the tools. I'm going on the port. I'm selecting COM port 7. I have connected my Arduino. Now I am just uploading this code. Now code is getting uploaded. Now as you can see, this LED is starting for 1 second and turning off for 1 second. Okay. This is how we can upload our code in our Arduino. Let's see how we have made this code afterwards. Okay. So let's see. For before going to the coding, we first understood what is the input and output devices. Okay. We need to learn these things first before doing coding. So input or output devices, often called as IO devices, is input output devices. It is kind of hardware component that human can operate or can interface with a controller. Controller is nothing but an Arduino. Okay, so it is a input output devices is nothing but our sensors and all the remaining devices were there. We can actually operate that. Human can operate the things. We are not able to see our code inside the Arduino, what is happening inside the Arduino, all of these things, and we are not able to see. But we can able to see the sensors and all these peripherals like relay, LED, buzzer, and sensors. We can able to see, no, and we can able to operate that sensors as well, and we can connect that sensor to the Arduino. So that is nothing but a input output devices. As name elaborates, Arduino are capable of delivering data. As we know, we can generate some data from by using Arduino, and Arduino can able to read some data from this there, right? So as we can see, there are a lot many sensors where there color sensor, gas sensor, IR sensor, ultrasonic sensors were there. These are the physical sensor. If we are keeping the ultrasonic sensor, that ultrasonic sensors is observing our environment, what changes is happening in the environment, right? So after the ultrasonic sensor, if some obstacle, suppose my hands is coming in between that, it's detecting my hands. So whatever the data that is getting, whether it's detecting hand or not, that is nothing but a data, right? So that data is that sensor is sent into the Arduino code, right? And Arduino, what Arduino is doing, that is listening to that particular sensor, that is reading the data from that sensor. So that's why Arduino is acting as an input. So we can say that whatever the sensors we are using, those are the input devices, because they are sending the data and our Arduino is reading that data, that reading particular data, right? That's why it's all these sensors as known as the input devices. And similarly, you can see here in this picture, there is LED, some DC motor, relay, buzzer, and some displays will be there. Those are the output devices. Why is this output devices? Because if we have connected some LEDs on the Arduino, we are saying that LED when to turn on. Now we are only saying them, so for 1 second we have to turn on, 1 second we have to turn off. That Arduino is sending them commands. That output device is controlled by this Arduino. So what we can say, Arduino is sending some data to the output devices. That's why it's called as output devices. Okay. Whenever our Arduino reading some data, that component is called as input sensor, input devices. And when our Arduino is sending data to some devices, those devices is called as output devices. Okay. So let's go ahead. Okay. So we'll learn something like analog signals and digital signals. So whenever we are connecting any sensors or devices like switches and all these things, we are connecting to our Arduino, right? Which can give them value in the form of two. There will be two options. Like now there we are connecting Arduino to one particular sensor, right? So how that Arduino will get to how the communication is happening in between that, how the data is getting exchanged in between that, right? So there will be two options, like one is the analog signals and one is the digital signal. Okay, analog communication and digital communication is the two options where there, how the sensors can communicate with our Arduino. Okay, there will be two possible options, analog communication and digital communication. Let's see first what is the analog communication means. Analog data refers to information which is continuous. So if you see the analog communication, you just see one generic example of our watch, normal analog watch, right? It has some three legs, right? One hour hand, one second hand, one will be minute hands. Three hands will be there. No? They are continuously moving, and that is nothing but one information that we are observing. So this information is continuously varying all the time. And similarly, if we have connected one sensor, this is one connected, we have connected one potentiometer. This is one knob. We can rotate this here and there. Okay. From left side to right side, we can move this, right? So how much I am rotating this knob depends on that, the analog values will going to be vary. Okay. So see, there is one waveform, right? So if I am moving this left side, this value will get decrease. If I'm moving in the right side, this values get increased. Similarly, I can connect any other sensor to this, and those value can change on the environmental condition. Suppose now I have my ultrasonic sensor. I have connected to A0. Now I am connecting my hand to that particular sensor. I'm moving here and there, right? I'm just moving my hands up and down, little bit here and there. Depends on my hands movement. That sensor is going to send the values to this Arduino, and Arduino will generate this waveform inside that. Right? Voltage is going to vary according with this, right? So how we can see, we can actually visualize on Tinkercad. For that, for now, I'm just deleting this LED built-in example. I'm deleting this example. I'm just checking for some another example, whether I have connected some. Okay, so I'm using one example called this. Okay, so I'm doing, this is one potentiometer. I can vary the voltage from this. So I'm just checking one multimeter. Okay, I'm taking one multimeter. I'm putting this in on voltage mode. I'm just connecting A0 pin to positive end of multimeter, and negative end I am going to connect on ground terminal of this. If I doing the start simulation, it's working. So it's showing 0 volt. If I'm varying this voltage, I'm varying this now, voltage across this A0 pin is also getting varied, right? So this is thing analog signals work. This is the continuous form. We can continuously changing this knob, and continuously we are getting some different values, right? So this is the analog communication. Instead of potentiometer, you can use some another sensors like that, right? Some analog sensors will be there available in market. So as you can see, Arduino has ability to sense digital and analog inputs to respond to this, right? Okay, let's move ahead. So similar like that, similar like analog signals, we have digital signals as well. So digital signal is nothing but it has only two definite stages. One is high, one is low. As you can see on this graph, there is one 5 volt line and there is one 0 volt line. So digital signal has only two levels. One is 0 and one is 5 volt. So as you can see on the analog signals, we have graphs like this. We can see at this level, we can see some different voltages. At this level, we can see the different voltage, 1 volt, 2 volt, 3 volt. And here we can see the 12 volt. We have different range of inputs in the analog communication, right? So similarly, in the digital communication, we have only two levels. One is low, one is high. As you can see in this image, there is one switch I have connected. If I am pressing this switch, the LED will turning on. Whenever I am pressing the switch, we are getting 5 volt supply. And whenever I am releasing this switch, we are getting 0 volt supply. Whenever I am getting 5 volt supply, I am turning on this LED. This is how it's working. And similarly, as you can see, digital signal can have only limited number of defined values. That is 0 and 1. Also, each can be any number of value. It's mostly is 0 or 1. So we can see some digital watches were there, right? Digital watches were there. So we can able to see 5 number, 2 numbers were there. I'm just saying for now I'm saying 0 and 1 is the only value. 0 is nothing but a low logic and 5 volt is nothing but a high logic. But how we can operate with like this? So if you see the 5 numbers, there will be 7 segment display will be like this. As you can see, A, B, C, D, E, F, G, H numbers were there. If I'm turning off this G color, G number is I'm turning off this G LED, then I can able to see the structure one arrangement like this 0. If I removing this G, then I am able to see as a 0. If I want to display 5 number, I am just removing this B and E. I'm turning off this B and E LED. Then I can able to see the structure like 5. So this is how I can able to use my digital communication for this such kind of clocks. Okay. So let's see this thing on the Tinkercad. So I'm just deleting this analog communication part. I'm deleting this now. So now what I can see, I'm just typing Arduino. There will be lot many examples over here that you can look for it. So I am connecting one. Okay, wait. Okay, I'm using one button example for that. So what is happening? Now I have connected my switch. One is going to ground and one end is going to 5 volt. Whenever I am pressing this button, this 5 volt will go into this terminal. Okay. So I am reading at pin number 2. I am just reading the value of this switch. What is the status of this switch? So for how I can check, I can just connect positive end on 2 and negative end on the one of the ground terminal. Okay. When I start simulating, so as we can see, there will be 0 voltage. Whenever I am clicking this, the 5 volt is coming. So at that time, LED is also blinking because we have set our code in this manner. Whenever switch is getting pressed, I am turning on the 30 number pin LED. So there will be this code is here. However, if you go on the code section, there will be, you have to go on the text. So you can able to see the actual Arduino code that we are going to implement. So we can just simply copy this code and we are going on Arduino software. Now I'm creating one new project and I'm deleting this thing and I'm pasting this code. And now I'm just uploading this code to my Arduino. So for that, I'm just connecting my Arduino. Whatever the switch connections we have to do, I have already done that connection. I just have to upload the code. Before the uploading code, we have to save our program and always give some proper naming to this code so that afterwards it will be easy for you to identify where we have save your code and with the what name. Okay, now this code is getting uploaded. So this mistake I have made again. So before uploading the code, we have to select first COM port, right? So what we have to do, we have to go on the tools, select the ports, and now COM port is changed because I have removed the Arduino and connected back. That's why COM port is changed. Now I am uploading this code. Now after uploading the code, as you can see, I have made some arrangements and there is one Arduino. Okay. So whenever I am pressing the switch, LED is getting turned on, right? So this is how you can check your code and upload it here on the software. Okay. Now let's see how we are did this code. Okay. Okay. Let's come to slides. So let's understand in the depth what is the digital pins and analog pins, then how we have connected that switch and LEDs, all those things, how we have actually implemented those things. Digital pins. So on Arduino Uno board, there are 14 digital pins from 0 to 13, and pins 0 and 1 used for serial communication, should not be used for any other purpose. Okay. So what does it mean? So as you can see, our Arduino has some digital pins. From 0 to 13, there will be 14 digital pins were there. And from that 0 and 1, we are not able to use it. Why? Because we are using it for communication. So if you want to upload the code, these two pins are getting utilized by the Arduino. So we cannot use these pins for any other sensors and components. So suppose if you accidentally connect some sensors on these two pins and you are trying to upload the code, then your code will not getting uploaded inside the Arduino. Why? Because these pins are getting busy by this sensor. So you have to remove that pins and upload it again. Then code will automatically get uploaded. Okay. So see, so what is the things? Digital input. Digital input pins sense the presence and absence of voltage on particular pin. So as we can see, so we have connected switch right here on the pin number 2. It's just detecting whether the voltage is there or not, whether voltage is present or absent. So currently voltage is absent, right? So that's why LED is turned off. So if I am uploading that, when I am pressing the switch, it's getting high voltage. That's why LED is turned on. So this digital pins is actually measuring the voltage. It's sensing the voltage, whether proper voltage is achieved or not. Okay. So digital input sense the presence and absence of voltage on particular pin. So before using these pins, we need to tell Arduino that which pin we are going to read. So we have connected our button on the pin number 2. We have to define in our code that we are going to use the pin number 2 of our Arduino, because there are lot many pins were there, right? So we have to define that pin. We are using it as an input or output, right? So reading input, we need to tell the Arduino which pin are going to use for reading the input. So we are using pin number 2. Therefore, we use the function called pin mode, pin comma input. So we are using pin number 2. That's why you can write it as pin mode 2 comma input to configure the pin as an out input. So let's go on this code. So let's see. This is the one basic code of the LED that we have seen. There will be, if you see the Arduino code, there will be two options, like two things. One is a void setup and another is a void loop. Void setup, inside that we have to define that which pin we are going to use and which device we are going to use. Now we are using one LED device, LED. Now I had told you that LED is output device. So why it's output device? Because Arduino sending information to that LED, right? So that's why it's an output devices. So we have to define whether this is a input device or output devices. Now pin mode is a LED built-in, comma output. LED we have connected pin number 13. Instead of LED built-in, we can write it as 13, right? Because LED is inbuilt LED is connected to the pin number 13. So pin mode, pin name, and the status, whether it is input pin or output pin. So LED is the output devices. That's why I mentioned it output. Okay. Similarly, if I have seen some another code like switch code, we have seen no switch is an input device because the Arduino pin is detecting whether the switch is pressed or not. This is looking for some data whether it's come or not. So we have connected that switch on the pin number 2, and this is the input devices that we have to mention. That is the input device: pin mode, pin name, pin number, and whether the status input or output. Similarly, we have connected LED. LED is on the pin number 13 and it's as an output device. That's why I am mentioning these things. So whenever we are doing the code, whichever device we are using, we have to mention it in the word setup. And we have to mention whether this device is input or output. Okay, this is the first step of doing coding. Okay, so next thing. Okay, now this thing is done. We have to mention that whether it's input or output. Now next thing, to read the digital input, Arduino uses function called digital read. What we are doing, we are observing the status of this switch, whether it is pressed or not, right? So what I am doing, now I'm going inside the while loop, digital read pin number 2. Now I'm observing it's not pressed, then this value will become 0. And I'm assigning one button state that will be equal to 0. If button is not pressed, button state will be equal to 0. If I'm pressing the button, I am getting the high voltage on this pin number 2. So button state will become high. High is nothing but a 5 volt. Okay. So this is how it's working. Button state is equal to high or low. It can be high or low depending on the state of the button. Right. So what I am doing now, I am providing some if condition. Now I am checking whether this button is pressed or not. If condition is doing what? Whether it's checking whether it is high or low. Now I am checking when button is equal to high. Now I'm just checking whether button is pressed or not. If button is pressed, then this condition will become true. Now see, there is one curly bracket here and one curly bracket is here, opening bracket and closing bracket. So if this condition is get satisfied, this condition is get true, means if the button is get pressed, this statement will go into execute. Whatever statements are there inside this curly bracket, that statements will go into execute. So there will be digital write LED built-in high. So now I'm saying that pin number 13, that is built-in LED, has to be turned on. High means turn on. Now if this button is pressed, I am turning on this LED. And if this button not pressed, it will go into this else part. And this will be LED will be low. Okay. Right. So this is how it's work. Now digital output. Similarly, like digital input, I explained digital output. We need to tell the Arduino that which pin is used for reading the input and writing the output. And pin mode is the pin comma output to configure the particular output devices, right? To generate digital output, Arduino uses function called digital write that we have seen in this example. Digital write command we are using. Now we have to turn on the LED. No, for that we have to mention the pin number 13 and it is high or low. We have to mention. So digital write. Now I am turning the LED on by providing this statement. There is one function digital write, this pin number and high. Okay, it's a little bit confusing, but still try to understand as much as you can. Okay, so if I am uploading this code, I have shown you that previously that if I press the switch, the LED will be turned on. This same code is there, right? Now similarly like this, there will be analog read function. So on the Arduino board, there will be six analog pins, right? A0 to A5. As you can see, there will be 6 analog pins, A0 to A5. There will be 6 analog pins. Okay. So what it does is not like unlike that digital pins. Like digital pins are measuring only 0 and high voltage. Right? 0 and 5 volt is there. That's measuring only that. But what analog sensor will do, if there will be two levels like 0 and 5 volts is there, right? So analog grid will break that 0 to 5 level in some steps, right? So there will be 0 to 1023 steps will be there. Now 0 to 5 volt will be two ranges. There will be some small steps will be there that analog grid can able to manage measure. So for example, like see, their analog values can be vary from 0 to 1023. Okay. So if the 0 volt is there on that particular pin, Arduino pin, so analog value will be 0. If the 5 volt I am giving to that particular analog pin, the value will become 0 to 03. If suppose 2.5 volt is coming, 511 value will come. Let's see on this Tinkercad. So stopping the simulation. I'm turning off this. Okay, I'm removing the switch. Let's take a quick look. Now I'm removing this code. Now I'm just going on this Arduino. Now I have to see analog serial example. Okay. So there I have connected one potentiometer. You can imagine it like any another sensor will be there. Now I have connected this pin to A0. Now multimeter I am connecting to A0 and the negative pin to the ground terminal. Okay. So when I am uploading the start, there will be code inside it. Code is here, text. Okay. This is the code. Now I have to see the serial monitor as well. Okay. When I'm starting the simulation, I can able to see the serial monitor is displaying some zero values. Serial monitor is nothing but a one simulation kind of thing. Whatever is happening inside the code, you can take a look on the serial monitor. Arduino also has some serial monitor. So now currently potentiometer is at zero state. That's why it's showing 0 volt. When I'm rotating this knob, the voltage on the A0 pin is also getting varied. Now is 5 volt. So similarly, analog values is 103, which is the maximum. If I connect, if I'm turning this on, and as I mentioned, I have connected on 2.4 volt, the value will be 49. Similar, like all the analog sensors will work like same like this. If I have to provide some supply and connect that data analog pin to this sensor pin, and you have to observe this analog reading. By depending on these analog values, you can do whatever you want. Suppose this value is coming greater than the 500 value is getting more than 500 value, then we can turn on some LED, turn on some fan. Suppose we have connected some analog temperature sensor and is getting some values similar like this 0 to 203. Suppose we have to, if temperature is rising more than our required, suppose temperature rising in the 500 value, then we have to turn on some fan. So what we can do similar like this statement, if condition we have provided in the our code, right? Okay, some if condition we have provided. If that sensor value is greater than 500, then we can turn on our LED. Similar like this, we can use this, and we can create lot many different applications from this. We can connect lot many another sensors were there. Okay, so every sensors and switches and all the electronic devices uses this kind of communication. One is analog communication, and another can be digital signal, digital communication they can use. Okay, so let's get back to slides. Okay, so this is the things were there. Okay. So this is from my side. So my colleague will going to interact with you for now. So yeah, over to you, Raju.
Yeah, Vipul, I'm sharing the screen. Now you stop, please. ఎస్ అందరూ కూడా ఇప్పుడు ఒకసారి ఏటీఎల్ కరికులంలోకి వెళ్దాం మనం. సో ఏటీఎల్ కరికులంలో ఇప్పుడు విపుల్ సార్ చెప్పిన విధంగా మనకి ఏమేమి ఉంటాయో ఒకసారి చూస్తాం. దాంట్లో ఆల్రెడీ సమ్ మాడ్యూల్స్ అనేవి ఉన్నాయి మనకి. సో ఇక్కడ చూడండి, ఏటీఎల్ కరికులంలోకి వెళ్తున్నాను నేను. మీకు అందరికీ కూడా తెలిసింది, ఆల్రెడీ అంతకుముందు సెషన్ లో ఓపెన్ చేసి చూపించాం. ఇక్కడ అండ్ ఐఓటీ మాడ్యూల్లో మీరు కనుక జాగ్రత్తగా చూస్తే ఆర్డినో అండ్ దాని కోడింగ్ ఏ విధంగా చేయొచ్చు అనేది ఉంటుంది. ఒకవేళ మనకి యూట్యూబ్ అవన్నీ ఓపెన్ చేసి చూడటానికి పాసిబిలిటీ లేనప్పుడు, దట్ మీన్స్ ఏదైనా ఇంటర్నెట్ ఇష్యూస్ వచ్చినప్పుడు ఈ ఫైల్స్ డౌన్లోడ్ చేసుకుని డైరెక్ట్ గా మీరు పెట్టేసుకోవచ్చు. దాని మీద క్లిక్ చేయగానే మనకి ఫైల్ ఓపెన్ అవుతుంది. సో వన్స్ ద ఫైల్ ఈజ్ ఓపెన్, ఓకే, ఈ విధంగా ఉంటుందండి ఫైల్. సో ఫిజికల్ కంప్యూటింగ్ అని చెప్పి ఉంటుంది. దీంట్లో మనం ఏమేమి ఉంటాయి ఏంటి. సో ఇప్పుడు ఇందాక విపుల్ సార్ చూపించిన విధంగా ఎల్ఈడిని ఏ విధంగా కంట్రోల్ చేయాలి, అదేవిధంగా స్విచ్చెస్ని ఎలా కంట్రోల్ చేయాలి, సో ప్రోగ్రామ్ ఏ విధంగా రాయాలి అనేది దీంట్లో ఈ స్లైడ్స్లో ఉంటాయి. సో ముందుగా ఏంటంటే సాఫ్ట్వేర్ని మనం ఇన్స్టలేషన్ చేసుకోవాలి. ఎలా ఇన్స్టలేషన్ చేసుకోవాలంటే www.arduino.cc అని చెప్పి సైట్ ఉంటుంది. దాంట్లోకి వెళ్ళి ఇందాక చెప్పిన విధంగా జిప్ ఫైల్ని డౌన్లోడ్ చేసుకోవాలి. డౌన్లోడ్ చేసుకున్న తర్వాత ఇక్కడ నేను నార్మల్గా సింపుల్ ప్రోగ్రామ్ ఆల్రెడీ అందరికీ తెలిసిందే, ఇది బ్లిక్ ప్రోగ్రామ్ అని చెప్పి. సో ఇందాక సార్ చూపించారు ఎలా కన్స్ట్రక్షన్ చేసుకోవాలి ప్రోగ్రామ్ అనేది. దాంట్లో మనకి 2 మోడ్స్ ఉంటాయి, వాయిడ్ సెటప్ అండ్ వాయిడ్ లూప్ 2 ఉంటాయి. ఆ వాయిడ్ సెటప్ లోకి వచ్చేసరికి మనం ఏ పిన్ ఇస్తున్నాము ఏంటి, ఏ పిన్ లో ఇన్పుట్ ఇస్తున్నాము, ఏ పిన్ లో అవుట్పుట్ ఇస్తున్నాము, అవి మనం రాసుకోవాలి. ఇక్కడ మనం వాయిస్ సెటప్ లో బ్లింక్ కోడ్ లో మనం ఏం రాసామంటే పిన్ మోడ్ 13 అవుట్పుట్ అని రాసాం. అంటే 13th పిన్ దగ్గర సార్ ఇందాక మీకు ఎల్ఈడి కనెక్ట్ చేసి చూపించారు, అవునా. 13th పిన్ అనేది అవుట్పుట్ కింద మనకి వర్క్ అవుతుంది. సో దాని యొక్క కనెక్షన్స్. సో ఇప్పుడు మనం ఎలాంటి టైప్ ఆఫ్ బోర్డు తీసుకుంటున్నాం, ఆర్డినో యుఎన్ఓ. సో ఆర్డినో యుఎన్ఓకి మనకి ఉండాల్సినటువంటి పిన్స్ కూడా మనం జాగ్రత్తగా చూస్తే, ఒకసారి దీన్ని నేను లార్జ్ చేసి చూపిస్తాను. సో చూడండి, ఈ ఆర్డినో పిన్స్ వచ్చేసరికి 0, 1 అలా 13 దాకా ఉంటాయి. దీంట్లో 0ని 1ని మనం ఉపయోగించుకోలేము, ఎందుకంటే అవి మనం ట్రాన్స్మిషన్ అండ్ రిసీవింగ్ ఉపయోగపడతాయి. 2 నుంచి 13 దాకా ఉన్నటువంటి పిన్స్ నే మనం డిజిటల్ పిన్స్ ని యూజ్ చేసుకోవడానికి పాసిబిలిటీ ఉంటుంది. అదేవిధంగా గ్రౌండ్ ఒకటి, అదేవిధంగా ఇక్కడ A0 నుంచి A5 దాకా ఎనలాగ్ పిన్స్ ఉన్నాయి. సో 5 ఎనలాగ్ పిన్స్ అండ్ 13 డిజిటల్ పిన్స్ అనేవి ఉన్నాయి. సో వీటిని మనం ఆర్డినో యూనో బోర్డులో తరచుగా చూస్తూ ఉంటాం. ఓకే, సో ఇక్కడ బ్లింక్ టెస్ట్ ని ఏ విధంగా చేయాలి. సో ఒకసారి మనం ఆర్డినో బోర్డులో ఇందాక సార్ చూపించిన విధంగా ఎల్ఈడిని 13th టెర్మినల్ కి గ్రౌండ్ కి మధ్యలో కనెక్ట్ చేసాము. ఎగ్జాంపుల్స్ లోకి వెళ్ళాలి. ఎలా వెళ్ళాలంటే ఐడిఈ సాఫ్ట్వేర్ ఓపెన్ చేస్తాము. దాంట్లో ఫైల్ మెనూ ఉంటుంది. ఫైల్ మెనూలో ఎగ్జాంపుల్స్ ఉంటాయి. ఎగ్జాంపుల్స్ లో బేసిక్స్ అండ్ బ్లింక్ లోకి మనం వెళ్ళాలి. సో ఎలా వెళ్ళాలి ఏంటనేది ఇందాక చూపించాను. దట్ మీన్స్ మనకి దీనికి కావాల్సినవి ఏంటంటే జంపర్ వైర్స్, ఎల్ఈడి బోర్డ్, బ్రెడ్ బోర్డ్, రెసిస్టర్స్, ఇలా మనకి డిఫరెంట్ థింగ్స్ ని ఉపయోగించుకొని మనం ఆర్డినో యుఎన్ఓలో ప్రోగ్రామింగ్ అనేది చేసుకోవచ్చు. ఫర్ ఎగ్జాంపుల్ కి ఏదైనా ఒక స్ట్రింగ్స్ ని అటాచ్ చేయాలి అంటే, దట్ మీన్స్ రెసిస్టర్ కనుక అటాచ్ చేయాలంటే రెసిస్టర్ ఇలా బెండ్ చేసుకుని యాడ్ చేసుకోవాలి. ఎల్ఈడి డైరెక్ట్ గా అలాగా మనం అటాచ్ చేసేసుకోవచ్చు. సో అదేవిధంగా ఇక్కడ చూడండి ఎల్ఈడి అండ్ రెసిస్టర్ కనెక్షన్ కూడా ఇచ్చారు బ్రెడ్ బోర్డ్ ఉపయోగించుకుని. సో అది తర్వాత సెషన్ లో ఇంకా మీకు విపులంగా చెప్తాము. సో ఈ విధంగా మనం ఎల్ఈడి అండ్ బ్రెడ్ బోర్డ్ ని కనెక్ట్ ఎల్ఈడి అండ్ రెసిస్టర్ ని బ్రెడ్ బోర్డ్ లో కనెక్ట్ చేసుకుని ఆ వైర్స్ మనం ఇక్కడ 13th పిన్ కి గ్రౌండ్ కి ఇచ్చాము. సో ఎలా వర్క్ అవుతుంది ఏంటి అనేది మనం ఇందాక ఆల్రెడీ విపుల్ సార్ చూపించారు. దట్ మీన్స్ ఎప్పుడైతే మనం దీనికి పవర్ అనేది కేబుల్ ద్వారా ఇస్తామో ల్యాప్టాప్ ద్వారా, పిన్ మోడ్ 13 అండ్ 13 డిజిటల్ రైట్ హై అంటే ఏంటంటే స్విచ్ అనేది ఆన్ ఆఫ్ కండిషన్ మనకు తెలుసు. నార్మల్ గా ఎప్పుడైతే స్విచ్ అనేది ఆన్ చేస్తామో దానికి ఏదైతే కనెక్టివ్ గా ఉన్నటువంటి డివైస్ ఉంటుందో అది ఆన్ అవుతుంది. ఇక్కడ మనం ఏ డివైస్ ఉపయోగిస్తున్నాం, ఎల్ఈడి వాడుతున్నాం కాబట్టి ఇక్కడ ఎల్ఈడి అనేది ఆన్ అవుతుంది అనమాట. సో దాని యొక్క కంట్రోలింగ్ ఎలా ఉంటుంది, దాని యొక్క కోడ్ చూడండి. ఇక్కడ వాయిడ్ సెటప్ అని రాసాము. సో పిన్ మోడ్ 13. సో పిన్ మోడ్ 13 అంటే ఏ పిన్ అయితే మనం ఇచ్చామో ఆ పిన్ ఇక్కడ మనం యూజ్ చేస్తున్నాం అనమాట. సో అదే విధంగా పిన్ మోడ్ తర్వాత డిజిటల్ రైట్. సో వాయిడ్ లూప్ లోకి వచ్చేసరికి మనం ఆన్ ఆఫ్ కండిషన్స్ ఇవ్వాలి. సో ఆన్ ఆఫ్ మీన్స్ సో స్విచ్ ఆన్ అయినప్పుడు దాని యొక్క డిలే, దట్ మీన్స్ ఆ ఎల్ఈడి అనేది గ్లో ఆఫ్ అయ్యి ఆన్ అయ్యి అవుతుంది, అవునా. సో అది దాని యొక్క డిలే, దట్ మీన్స్ ద టైం పీరియడ్ ఎంతసేపు ఆన్ అయ్యి ఉండాలి, ఎంతసేపు ఆఫ్ అయ్యి ఉండాలి. 1 సెకండ్ ఫర్ ఆన్, 1 సెకండ్ ఫర్ ఆఫ్. 1000 మీన్స్ ఇవి 1000 మిల్లీ సెకండ్స్ అనమాట. సో 1000 మిల్లీ సెకండ్స్ అంటే 1 సెకండ్ కింద తీసుకోవాలి. సో 1 సెకండ్ కి ఆన్ అవుతుంది, అలాగే 1 సెకండ్ కి ఆఫ్ అవుతుంది. ఇది ఇందాక మనం ప్రోగ్రామ్ లో ఎల్ఈడి బ్లింకింగ్ గురించి చూసాము. సో మీకు డైరెక్ట్ గా ఏటీఎల్ కరికులం ఓపెన్ చేసుకుని ఐఓటీ మాడ్యూల్ లోకి వెళ్తే ఇవన్నీ కూడా థియరిటికల్ గా దట్ మీన్స్ నేర్చుకోవచ్చు. సేవ్ చేసుకుని పెట్టుకోండి ఈ విధంగా డౌన్లోడ్ చేసుకుని. ఓకే, ఇవాళ సెషన్ లో మీరు ఆర్డినో ఐడిఈ సాఫ్ట్వేర్ గురించి అన్ని తెలుసుకున్నారని చెప్పి అనుకుంటున్నాను. So thank you for one and all to giving this valuable opportunity to us. Thank you for Government of Andhra Pradesh, Department of School Education, Samagra Shiksha, SCRT, UNICEF and Vigyan Ashram and Diksha AP channel ni andaru kuda like and subscribe cheyandi. ఎవరైనా ఒకవేళ సబ్స్క్రైబ్ చేయకపోతే ఇప్పుడు సబ్స్క్రైబ్ చేయండి. కొత్త కొత్త వాల్యుబుల్ సెషన్స్ ని వినొచ్చు మీరు. సో దాని ద్వారా కొత్త కొత్త థింగ్స్ నేర్చుకోవచ్చు. అదేవిధంగా ఇక్కడ మేము ఏదైతే చెప్తున్నామో ఆ సెషన్స్ ని మీరు ఓన్ గా ట్రై చేయడానికి ప్రయత్నించండి. సో మీకు ఏటీఎల్ మ్యారథాన్ రిలేటెడ్ క్వైరీస్, సో ఏటీఎల్ మ్యారథాన్ ఫామ్ ఫిల్లింగ్ లో ఇబ్బందులు ఉన్నా, లేదా ఏదన్నా ప్రాజెక్ట్ కోడింగ్ లో ఇబ్బందులు ఉన్నా మాకు డైరెక్ట్ గా మెయిల్ ఆర్ కాల్స్ చేయొచ్చు. సో స్టే ట్యూన్ టు అవర్ నెక్స్ట్ సెషన్. మా నెక్స్ట్ సెషన్ కోసం ఎదురు చూస్తూ ఉండండి. అందరూ కూడా మీ యొక్క సపోర్ట్ ని మాకు ఇవ్వండి. ఫీడ్బ్యాక్ ఫామ్ మీకు ఇప్పుడు వాట్సాప్ గ్రూప్స్ లో షేర్ చేస్తాము. ఫిల్ చేసి మీ యొక్క ఫీడ్బ్యాక్ ని మాకు అందించండి. థ్యాంక్ యూ ఫర్ వన్ అండ్ ఆల్.